Here's a challenge. Can you take this expression and break it down into two smaller pieces that multiply back to the original expression? Seems tricky, but I'm going to show you a method that makes it a piece of cake. Welcome back to the Pyramids of Algebra, where every lesson builds up your math skills. Last time we completed these lessons, and next we're going to unlock the secret to factorizing algebraic expressions. In this video, I'll reveal 3 critical keys that will break down this process step by step, making it easier than ever for you to understand. Starting with the first key. In this section, you'll learn the critical skill needed to factorize algebraic expressions. The critical skill is finding the highest common factor. Do you remember what a factor is? Factors of a number are those numbers that divide into it evenly. For example, the factors of 6 are 1 and 6 and 2 and 3. But what are the factors of an unknown number such as y? Since there is little information about y, it is only certain that it can be divided by 1 and that it can be divided by itself. This means the factors of y are 1 and y. Now the factors of 6y, which is 6 times y. The factors are not only 1, 2, 3, 6 and y, but also 2y and 3y and the term itself 6y, since every factor works in pairs. So how do we find the highest common factor? Let's look at numbers first. What is the highest common factor of 12 and 30? If you took your time and wrote down the factors for each, the highest common factor is simply the largest number that is common in both lists. In this case, the highest common factor is 6. We use the abbreviation HCF to say the highest common factor. Now looking at the following algebraic terms. To find the highest common factor, step 1, find the HCF of the numbers exactly how we worked it out previously. The HCF of 12 and 30 is 6. Step 2, check each variable, only take out the variable that is common in both. If common in both, take out the smallest power. Starting with the variable a. It isn't common in both, so it is not included in the highest common factor. Next, moving on to the variable b. We notice we can see a b in each term. However, we need to be careful. We can't take out a b squared as a factor for both because the second term does not have a b squared. We can only take out the smallest power, which is a b, giving us a highest common factor of 6b. So what exactly is factorizing expressions, and why is the highest common factor so important? Let's learn about this in the second key. In our previous lesson, we learnt the skill of expanding. This is the process of removing the brackets from an algebraic expression. What operation is hidden between the outside term and the brackets? Yes, multiplication. Remember, the shortcut process to expand is to multiply the outside term by each term in the brackets, giving us the following. Now think of the reverse, starting with this expression and going backwards and adding in the brackets. This is called factorizing. If expanding, we need to multiply, and factorizing is the reverse. Can you guess the operation you need to complete to factorize? Yes, divide. Therefore, to factorize, step 1, write in the brackets. Step 2, write the highest common factor outside the brackets. Step 3, divide each term by the highest common factor. First, dividing 12x by 4, this equals 3x. Next, positive 8 divided by positive 4, this equals 2. Did you know there is another method to factorize expressions? Some say it's the easier method. Let's learn this next method in the third key. Now, if you had a choice between multiplying and dividing, what would you choose? Most people prefer to multiply. If we were given the following expression, and if we were asked to factorize it, if you prefer to multiply rather than divide, then this next method is for you. Step 1 is the same. We write down the brackets. Step 2 is also the same. Write the highest common factor outside the brackets. In this case, it is 2. For step 3, we treat it like an expanding question and try and find the missing value. In this case, 2 times what gets you 2x? Well, 2 times x gets you 2x. Next, positive 2 times what gets you negative 28. Firstly, a positive times a negative gets you a negative answer. Then 2 times 14 gets you 28. Remember, both methods are perfectly fine to use. You'll get the correct answer either way. The awesome thing with this skill, if you wanted to confirm your answer and see if you were correct, you can check. To do this, expand the expression after you are finished, and it should be the same as the starting question. If it is not the same, you have made a mistake and you can go back and check. Which method do you prefer? Comment below and let me know. You now know all the key information on this concept. However, can you solve all exam style questions? Watch this next video to master questions easily.